Hello and welcome to this R tutorial. In this tutorial, we are going to solve our business problem using the k-means algorithm in R. So let's start by setting a working directory. So we go to Session, Set Working Directory, and we click on Choose Directory. Then we pick our folder Machine Learning AZ, section k-means clustering, and we click on Open. Okay, now the first step is to import the mul dataset. So let's introduce a new code section with the comment importing the mul dataset, and we import our dataset by typing dataset, left arrow, read.csv, and in parentheses, mul.csv. Okay, let's select this line and hit Ctrl+Command plus Enter to execute, and our dataset is now imported. Let's click on it to see it. Okay, so let's re-explain what this mul dataset is about and what our mission is. There is a big mall in a specific city that contains informations of its clients, the clients that subscribe to the membership card. When the clients subscribe to the card, they provided their information like their gender, their age, and their annual income. And because they have this card, they use it to buy all sorts of things in the mall, and therefore the mall has the purchase history of each of its client member, and that's how they obtain the last column here, which is a spending score. So as a reminder, the spending score is a score that the mall computed for each of their clients based on several criteria, including, for example, their income, the number of times per week they show up in the mall, and of course the amount of dollars they spent in a year. And based on all this, they computed this metric that takes values between 1 and 100, so that the closer the spending score is to 1 and the less the client spends, and the closer the spending score is to 100, the more the client spends. And eventually, after collecting this dataset, the mall company hired you as a machine learning scientist to segment their clients into different groups based on these two metrics, the annual income and the spending score. And since the mall has no idea of what these client segments might be, this is typically a clustering problem because we don't know the answers. So now let's start our mission and use the k-means algorithm to find out what those clusters of clients might be. So here we just imported the dataset, and now let's create a variable x that will only contain the two columns we are interested in, the annual income and the spending score. So here we write x, left arrow, dataset, and then in square brackets, we're going to put the two indexes of our two columns of interest. That is, if we go to dataset, since indexes in R start at 1, the indexes of our two columns, annual income and spending score, are 4 and 5. So here in the square brackets, we put 4, 5, which means that we go from 4 to 5. Okay, let's select this line of code and execute it. Perfect. It created the array X of our two columns, which we can visualize here by clicking on X. Alright, now we have all our data well imported and well prepared, and we are ready to move on to the next step. And that's when things start to get interesting. Indeed, right now we are going to start using k-means. So remember, when we use k-means, we have to specify the number of clusters. But the problem here is that we have no idea of how many clusters of clients we are looking for. So we could fit k-means several times on our dataset with different numbers of clusters to test different outcomes. However, there is a much faster way that allows us to find the optimal number of clusters to use with k-means for our problem. And we are, of course, going to use the elbow method. So let's introduce a new section with the comment using the elbow method to find the optimal number of clusters. And in this code section, we're going to make a for loop to plot our elbow method chart. So since there are random factors in k-means, we can obtain slightly different results by using k-means several times. So in order to all get the same result, we are going to set the same seed. And to do this, we type set.seed, and in parentheses, we can pick whatever number we like. Let's pick 6. Then we are going to use a for loop to compute some different within cluster sum of squares for different numbers of clusters. And we are going to place the different within cluster sum of squares in a vector. So let's start by initializing this vector by typing WCSS, left arrow, vector, and empty parenthesis. So that just initialized an empty vector, and now we're going to use the for loop to populate it with the different within cluster sum of squares. So let's write 4, and in parentheses, I in 1:10. So in for loops in R, the lower bound and the upper bound are included. So here, that means that I is going to take the values from 1 to 10 included. And then at each iteration, we directly compute the within cluster sum of squares for each number I of clusters by writing sum, and in parentheses, k-means xi to fit the k-means algorithm to our dataset x with I clusters. And by doing that, we actually created an object of the class k-means in R. And if we select k-means here, press F1 and then scroll down to value, we see that this class has an attribute called withins that computes the within cluster sum of squares. So let's of course use it and type k-means xi and then $, withins. Alright, now thanks to this loop, the WCSS vector is populated with the 10 different within cluster sum of squares for the 10 numbers of clusters 1 to 10. Perfect, so now all we have to do left is plot the graph. So we type plot, and in parentheses we first input the x values, that means 1 to 10, then the y values WCSS. Okay, then let's select plot and press F1. We can specify a type of plot, P to have only points, L to have only lines, and B for both. And we are going to choose both. So B. Then let's give a title to our plot by typing main equals paste and in parentheses clusters of clients. Then we can give a name to our X label. So let's input xlab equals number of clusters. And we give a name to our y-axis, ylab equals WCSS.